Okay. So before break, we talked a little bit about the number I, right? Called the imaginary number, and it came from an equation, x squared equals -1, and trying to figure out, well, what's squared equals -1. And so along that line, we came up with defining I, and I was equal to what? It's the square root of -1, right? And if you were to plug in I into this equation, you'd get -1. So that tells us that I squared is equal to what? -1, right? It's a solution to this equation. What squared equals -1? Well, I squared equals -1. And so we're going to build off of that. So I have a little table on the left-hand side, and we're going to find the values of I to the 0 to I to the 7th, and simplify as much as we can with these. What do you think I to the 0 would be equal to? What is 5 to the power of 0? I heard 0, I heard 1, I heard 5. 1. What's 100 to the power of 0? 1. What do you think I to the power of 0 is? 1. Anything to the power of 0 is equal to 1. Anything to the power of 1 is equal to itself, so I to the power of 1 would be I. We just said what I squared is. -1. We wrote it over here. I squared equals -1. Okay, how about I to the 3rd? Any idea? What do you think, Elijah? Why? So I to the 3rd is I times I times I, right? That's what I to the 3rd means. What's I times I? So this is the same thing as -1 times I. And what's -1 times I? -I. Right? Because I squared is -1, so -1 times anything, right, makes it it's the opposite sign, right? So it's -I. How about I to the 4th? Which is? It's 1. So I to the 4th, one way to think about it is I squared times I squared, and that's -1 times -1, which is +1. I to the 5th is I. How do you know? Okay, so you're thinking this is I squared times I squared times I. And so this is -1 times -1, which is 1 times I, so you're just going to end up with I. Yeah, one way to think about it. I to the 6th? How do you know? Oh, you're looking for a pattern. You're seeing a pattern. You're hoping it continues that way. Well, it is going to be -1. And there is a pattern. And what do you think I to the 7th is going to be? -I. Okay. So there's a pattern of 4 here, and if we continue this, the pattern would continue. It goes 1, I, -1, -I. And if it helps you, you could draw a real number line and an imaginary number line. And they cross at 0, 0. And so if I go to the right 1, so this is your value 1 here, right? If I go to the left, I'm at -1 over here. At the imaginary, I'm at I, positive I, and down here I'm at negative I, right? If you remember kind of how we went around the circle with trig, right? So you got 1 goes to I goes to -1, -1 goes to negative I, and negative I goes back to 1, and it goes around the circle. And that's what's happening here, right? So this would be I to the 0, I to the first, second, third, I to the fourth, fifth, sixth, seventh, I to the 8th, I to the 9th, 10th, and so on. Okay. So what is I to the 123rd place? Why? Someone said negative I. Why? Suzuka, that was you, huh? Okay, so 120 would be here, and then go 3 more. Good. How do you know 120 would be there? Okay, so the key is you divide by 4, old style, and you look at the remainder. So 4 goes into 12 3 times, and then 4 doesn't go into 3. So this is, sorry, I'm messing up here. So 4 goes into 12 3 times, and then it doesn't go in at all, right? So what's our remainder going to be? So we're going to get a remainder of 3 left over, right? So because 4 times 30 is 120, and then when you subtract that, you're going to get a 3 remainder. And so the remainder is really what you're after. So this, if the remainder is 0, you're at 1. If the remainder is 1, you're at I. If the remainder is 2, you're at -1. And if your remainder is 3, you're at negative I. And those are the only remainders you'll get if you're dividing by 4. And so this is equivalent to I to the 3rd, because 3 is our remainder. And that's equal to negative I. Okay. How about that? Let's do one more. What if I have negative I to the 1, 2, 3, 4, 5 power? 12,345. What's that? I? Okay. So this power right here is the power of I or the power of negative I? It just belongs to I. So you're going to have to find out what I to the power is, and then you're going to have to multiply it by a negative. Okay? So this is going to be negative times something, and it's going to be I to whatever the remainder is going to be. And so when you divide 12,345 by 4, what's our remainder? Get a remainder of 1. Okay, so if the remainder is 1, then I to the 1 is 1. And so we end up with a negative times I. So answer negative I. Okay. All right. Now let's apply this. We're going to do some simplifying problems and multiply and work through things like this. So here we want to simplify this complex number. 2 minus squared minus 4 times 2 minus I. And so when we do, we have 2 minus I squared. So that's 2 minus I times 2 minus I. Minus 4 times another 2 minus I. And when you multiply out, you're gonna treat I like a variable at first, like it would be an X or a Y or anything like that. So we're gonna distribute 2 times 2 gives me 4. 2 times negative I is negative 2I. Negative I times 2 is another negative 2I. Negative I times negative I is positive I squared, right? And then we got negative 4 times 2, which is negative 8. Negative 4 times negative I is a positive 4 times I. Okay. After you multiply things out, so I is not a variable. You treat it like a variable at first, but I is not a variable. So you see I with any power, you can simplify it. So I squared is what? Negative 1. Okay. And so we're gonna be changing that to a negative 1. So we have a 4 minus 4 times I plus a negative 1 or minus 1 if we want, minus 8 plus 4 times I. And negative 4 times I and positive 4 times I add to 0. And so now we're just left with 4 minus 1 minus 8, which is negative 5. Okay. I'm going to have you try that on your own for this next one. 4 minus 3I squared minus 16 times 4 minus 3I plus 1. what do we get? Negative 56 plus 24i. Here it is. Here's the work. So compare your work with mine, and if you did not get it, see if you can figure out where it went wrong. Careful. 9i squared. I squared is negative 1. So that's 9 times negative 1. That's how I'm changing that to a negative 9. Okay. And then you combine like terms. You treat it like treat I like a variable. You combine all the, I highlighted all the real numbers in yellow, all the imaginary numbers in green, and you combine like. All right, so the last thing I want to talk about is how to work with fractions or division with complex numbers. Okay, so I is equal to what? Definition: I is equal to the square root of negative 1. And with fractions, we already learned we can't have square roots in the denominator. So if I is in the denominator of a fraction, you have a square root in the denominator of a fraction, you can't have that. Okay, so this next example, number 4, says to simplify 3 minus 2i over 2 minus 3i, we have a square root in the denominator. In Unit 1, okay, back in August last year, okay, we talked about, we didn't have I, but we had square roots in the denominator. We talked about how to get rid of those. It's been a while. Anybody remember the trick? What's that? It worked with simple cases, but when you have two terms, there's something that like we needed something special when your denominator had two terms. Close. There's something called a conjugate in mathematics, okay? So if, in this case, we have a 2 minus 3i, you got your real part, your imaginary part. Its conjugate, the real part would stay the same, and then you'd have the opposite of the imaginary part, so plus 3i. That would be the conjugate. And the important part is when you multiply the conjugates together, it gets rid of the imaginary part, and you end up with a real number. So I will go away when you multiply conjugates together. It doesn't just work with I, but if we had a square root, like square root of a real number, so like square root of 3 or something like that, conjugates would also apply to that. So if I have, let's say, what would the conjugate of 1 plus I be? 1 minus I. Okay. What would the conjugate of negative 3i minus 4 equal? 3i what? Minus 4. The real part stays the same. The imaginary part changes. Sign. Okay. So on number 4, it's the denominator that we need to change, not the numerator. So we want the conjugate of the denominator. So it'd be 2 plus 3i. And with fractions, we can keep equivalent fractions as long as we multiply the top and the bottom with the same thing. So you do not multiply the top by its conjugate. You're just keeping it the same as what you're multiplying the denominator by. So here we got 3 times 2, which is 6. 3 times 3i, which is 9i. Negative 2i times 2, which is negative 4 times I. And negative 2i times 3i, which is what? negative 6i squared. And what's negative 6i squared equal to? Positive 6, because this is a negative 6 times a negative 1. I squared is negative 1. So keep that in mind. We'll come back to that and use that. In the denominator, we got 2 times 2, which is 4. 2 times 3i, which is 6i. Negative 3i times 2, which is negative 6i. And negative 3i times positive 3i, which is negative 9i squared. But what's negative 9i squared really? Positive 9. Okay. Now, when you multiply conjugates together, the two middle terms will always be the opposite of each other and will always zero out when you add them. And that's why we're getting rid of the imaginary part. So in my numerator, I have a 6 plus another 6. This is positive 6 here, right? And that gives me 12. And then a 9i minus 4i gives me positive 5i. That's in the numerator. In the denominator, I have 4, and then we said that this right here is a plus 9. And 4 plus 9 is 13. And now we've got rid of the imaginary part in the denominator and have a simplified equation. I got one more for you to try, just like this. Try it on your own though. 5 plus 2i over 5 minus 2i. That. So you should be getting 21 plus 20i all over 29. Check your work.